Programming landscape has evolved a lot over the years. Year by year, there are numerous programming languages getting created, due to which this industry is quite dynamic and volatile. However, there are few languages that have maintained their popularity since the early days of their incarnation. Java is one of them. Java programming language has been ranked among the top 5 programming languages by every research carried out till the date. According to a report by Indeed.com, an average Java developer earns around 105,000 US dollars in USA and around 8 lakh rupees in India. But the process of getting there is not easy. You'll have to pass through the stages of programming assessments and technical interviews. That being said, I welcome you all to this extensive session on most important Java 8 interview questions. With this session, we'll provide you with answer to the most commonly asked top 20 Java interview questions. But before we do that, please make sure to hit that subscribe button and bell icon so that you never miss any update from Intellipaat.
The first basic question we have here is, what are the new features that were introduced with Java version 8? Now there are many features that came in with Java 8 version. Let's look at some of the important ones at a glance. The first one is Lambda expression. Java Lambda expressions were Java's initial step towards functional programming. A Java Lambda expression, often known as Lambda function, is an unnamed expression or function that is recast as a parameter for any further function. In Java, Lambda expressions are functions that may be shared as an object. It can also be used to refer to an object. Lambda expressions need more compact coding, and it also offers a technique of executing Java 8 functional interfaces. These expressions allows users to define a single functional unit that may be carried over several lines of code. Next we have is functional interfaces. These are the types of interfaces that can contain only a single abstract method. Commonly, these interfaces are recognized as single abstract method interfaces. Then we have method references. These are the references that use a function as a parameter to request a method. Fourth important functionality we have is default methods. The default method is a method that offers an implementation of methods within interfaces, enabling for a building of interfaces. Next up is Stream API. The Java Stream API is an abstract layer that implements the pipeline processing of the data. The sixth feature that Java version 8 adds up to the list is Advanced Date Time API. In Java SE 8, the latest updated Joda time stimulated APIs are introduced to overcome the disadvantages of previous versions. Then we have Optional. Optional is a wrapper class included in Java version 8 that is used to control the imaginary values and assist in additional processing based upon the value. Finally, we have Nashon. A JavaScript engine Nashon is a device variant of JavaScript engine introduced in Java version 8 that provides JavaScript performance in Java to succeed Rhino. Next question we have on our list is, what do you mean by functional interfaces in Java? Functional interfaces along with Lambda expressions and method references are featured in Java SE 8 to make code more legible, clean and easy. These are the interfaces that ensure that they only feature one abstract method. It is utilized and executed by expressing the interface with the @function interface annotation. As previously stated, functional interfaces can only have one abstract method. They can, however, include an unlimited number of default and static methods. There is no need to use abstract keyword in functional interfaces since it is optional to use the abstract keyword because the method specified within the interface is abstract by default. Lambda expressions are also examples of functional interfaces. Then let's move to the third question on our list. Describe the method reference concept in Java. Functional interfaces in Java and Lambda functions are prerequisites required in order to grasp grip over method reference in Java. As we all know that a method is collection of statements that perform some specific task and returns the result to the caller. But what if I tell you that there is possibility that method can perform some specific task without returning anything? Methods allow us to reuse the code without retyping the code. Let me help you understand this by taking an illustration of method by value. In Java 8, we can use the method as they were objects or primitive values, and we can treat them as a variable. Let me show you how to do this with a hands-on demonstration. We will visit the code editor in order to do that. Now, in order to begin with the coding implementation, let's first create the Java file. We'll name this file as method reference.java. Now we have got the public class over here. We'll create one interface and we'll name this interface as sayable. Now inside this interface, we'll create an empty method without any body and we'll name it as void say. Now let's come to the method reference body, and here we'll create one more function which is static in nature, and we'll name it as say something. Inside this function, we'll write a statement, hello, this is method running, and now we'll enter into the main block. Now inside this main block, we'll call the sayable interface and we'll create the object of it, and we will use a method reference syntax by calling method say something. And again we'll write the calling to the same object, that is sayable dot say. Now let's run the code and see what output we are getting out of this. So with the help of method reference, we are actually implementing the class method with the help of say function. So basically, method references are used when the lambda expression is declaring a function and doing nothing more, or it is used to pass a function as a value or as a variable. I hope this is clear to all of you guys. Now let's move to the next question. Explain the syntax of lambda expression in brief. The syntax of lambda expression in Java is made up of three major parts. We are going to look at them one by one. The first one is argument list. In Java lambda expression syntax, the argument list is written inside the brackets. The argument list might be empty or contain a parameter or parameters. Here you can see that there are multiple argument types. No arguments, one argument, two argument, with explicit argument type as well. So here you can see that all of them are mentioned inside the bracket. Now next comes the arrow token. The arrow token is represented by an arrow in Java lambda expressions. It is used to link the parameters in the argument list to the expressions of the body. Then comes the body part. Body part in Java lambda expression is written just after the arrow token. The body comprises the expressions that needs to be executed. Now let's move to the next question on our list, that is fifth question. What are streams in Java 8? Java implements a new package known as java.util.stream in Java version 8. The package contains many different interfaces, classes and enum that allow the user to perform functional style operations on the elements. The entire idea of the Java stream is to facilitate functional style processes on streams of elements. A Java stream is not considered a data structure. However, we might consider Java stream to be an abstraction. It's not a collection or set where we can store data elements. A stream is basically a reflection of a non-changeable compilation of procedures that are used in any classification of data. In simple words, a Java stream is a package that contains various classes and interfaces which are capable of doing the iteration of its own elements internally. When we deal with the iteration feature of Java collections, we must manually iterate the components. To sort of give you an example, we can use a Java iterator or Java for each loop in order to work with Java iterables. After this, the next question on our list is what is the difference between collections and streams? The first easy difference that you can highlight is that collections were introduced with Java 1.2 version, whereas streams came up with the Java SE8 release. The collection framework is used to store data. In simple words, it is used to store a set of objects, whereas streams are used in computing the data. What I mean by computing here is that it is used in the computation of set of objects. In collection API, the iteration of element can be done with the help of both split iterator and iterator, whereas in case of stream API, the users are not allowed to iterate the elements of the stream using split iterator and iterator. They can do that with for each loop. In the collections, when the collection object is computed entirely, then only the user can add the elements to the object of collection. Whereas in the case of streams, when the stream object is computed entirely, then only the user can add elements to the object of stream. In simple words, we can say that streams object are computed on the demand of the user. Whenever a user is using collection API, they can iterate and use elements from the object of collection at any number of times. But whenever a user is using stream API, they can iterate and use elements from any object of the stream only a single time. If I have to explain these terms by providing examples, then I would say collections are like movies stored on DVDs. Like a DVD, a collection holds all the values that the data structure currently has. Every new element has to be computed before it can be added to the collection. Whereas you can consider Java Edge Stream as a movie streamed over the internet. Like video streaming, computation of values is done as per need. The next up on our list, what are the default methods in Java 8? The methods of Java interface, which comprises the body solely, are acknowledged as the default methods in Java. These methods, as the name implies, use default keyword. The convenience of working with these default methods is backward compatibility. Backward compatibility means if JDK transforms any interface without the default method, then the classes which implemented this interface will definitely break. However, if the user includes the default method in the interface, they will be able to give the default implementation. This will not have any impact on the implementing class. Then we have a hands-on approach based question here. Find minimum and maximum number for random Java stream. And to build a solution for this question, we'll visit the code editor. Now let's first create the program file. We'll name this program file as stream mean and max dot java. Now first of all, let's create the program file. We'll name this program file as stream minimum and maximum dot java. Now before we write functional programs, first of all we'll need few libraries. Let's import them first. We will import java dot util dot comparator. Okay, I is capital here. Import java.util.comparator. Next, we'll import java.util.stream library because we'll be working with stream here. Then we'll move to our public class, that is stream min and max. Now inside this class, we'll create the main method and we'll find the maximum variable first, and it will be equal to, first we'll enter the stream dot off, and the numbers that will be passing are 1 2 3 4 5 and 6. Now to this we'll apply the max comparator, and the parameter for comparison will be the value, that is comparator dot comparing integer value of. Now this statement written right here will allow our comparator to compare the elements and sort of find out the maximum element out of them. Now we want to get that element, so at the end we'll use get function as well, and then semicolon. Now the next thing we want is the minimum variable. So for that we'll create new variable named as minimum. Again we'll pass the stream, that is 1, 2, 3, 4, 5 and 6. And now here we'll use the minimum comparator, and the parameter for comparison will be the same. And we will use get at the end. Now we'll print the maximum element first, and we'll also print the minimum number. There is one more mistake in our code. So the type should be capital I integer, that is integer. So let's run the code and see what we are getting out of this code. Now here you can see that the minimum number is 1 and maximum number is 6, which means our code works fine. So basically what we have done here is we have taken the stream input and then we have passed it to the max comparator to find out which element is maximum. And similarly for minimum element, what we have done is we have passed the stream and we have calculated the minimum element out of the stream. I hope this implementation is clear to all of you guys. Now let's move to the next question on our list. Explain optional in Java SE8. Optional class can assist in drafting a clean code without practicing multiple null tests. By working with optional, we can define substitute values to restore or alternate code to run. This makes the code more understandable because the actions which were received are now obvious to the developer. Optional can also be defined as an object or container which might contain or not contain a non-null value. You need to improve the java.util package to run this class. Every Java programmer is familiar with null pointer exception. It can crash your code and it is very hard to avoid it without using too many null checks. So to overcome this, Java 8 has introduced an optional class in java.util package. The 10th question we have for you guys is explain stream operations. Java streams support two distinct sort of operations: intermediate operations and terminal operations. Intermediate operations are basically the activities that return a stream, allowing the user to chain numerous intermediate actions without using any semicolon, as we do in other programming languages such as Scala, let's say. On the other hand, we have terminal operations. These are the operations that are mostly void and null, and if they are not null, they return a non-stream as a result. Have a look at these different functionalities involved in stream operations. Here you can find out that collect, count, for each, minimum maximum that we have used in previous program, reduce, toArray, find array are all terminal operations. These operations will return the final result to operation pipeline. And then we have intermediate operations such as distinct, map, FlatMap, limit, skip, which have come with Java 8 version. Basically these are the stream operations, right? And they will return another stream and then can be chained to form a pipeline of operations. I hope you get this difference now. Let's look at next question on our list. What is the simplest technique in Java 8 to locate and remove duplicate entries from a list? We can use stream.distinct method to remove duplicates from a stream in Java 8 and beyond. The distinct method behaves like a distinct clause in SQL, which eliminates duplicate rows from the result set. The distinct is also a standard method, which means it will return a new stream without duplicates, which can be used for further processing. Like other methods of stream class, I mean map, FlatMap, or filter, distinct is also a lazy and it will not remove duplicate elements until you call a terminal method on stream like collect or for each. Now let's visit the code editor and sort of understand how you can remove duplicates from a list with the help of Java 8 program. First things first, let's create a program file which is named as dupe removal.java. Now let's also load some important libraries that we'll need down the line. So the first package we have is import java.utils.arrays. Then we'll import java.util.list. Next we'll import java.util.stream.collectors. Now inside this class, we'll first create the main method. Now inside this main method, we'll create the list of integers and we'll name it as with duplicates. And let's say we pass array as list 10, 10, 20, 20, 30, 30, 40, 50. Alright. Now let's print this list. Now next we'll create the list that do not have any duplicates, and for that purpose we'll name this list as without dupes, and we'll convert this with dupes array to the stream, and after that we'll apply the distinct method, and then we'll collect the unique items to the list. And now let's print the list that do not have any duplicates. Now let's run this code. See, here you can find out that the duplicate valued list has elements twice or thrice, but without duplicate list has no duplicate element. And all we have done is we have taken the list, we have converted it into stream, then we have applied the distinct function, and after that we have collected the distinct or unique elements from that stream. I hope this programming implementation is again clear to you guys. Now let's move to the next question. The question says, explain the string joiner function in Java version 8. In Java version 8, a new class was introduced in java.util package which is called the string joiner class. With the help of this class, a user can merge various strings by separating them with some delimiters. String joiner class also helps in adding prefixes and suffixes to the string. To help you understand the use case of this function, let's visit the code editor and build a new Java program. First of all, let's create the new file and we'll name this file as string joining.java. Now we'll require few libraries, so let's import them. The first one is import java.util.string joiner. Now inside the string joining class, we'll create the main method and here we'll create the object of string joiner and we'll add delimiter as semicolon. Now let's add few elements to this joiner and then we'll print them. The first one is Alex, then we'll add Intellipaat, Java, then interview and questions. Now let's print and see what output we get out of this joiner object. Here you can see that all the different words have been separated with semicolon because we have used delimiter as semicolon. So I hope the functionality of this string joiner class is clear to all of you guys. That brings us to the 13th question on our list. Can we extend a functional interface from another functional interface? I don't think this is a difficult question at all, because we have mentioned throughout the session that functional interfaces are the interfaces that only contain an abstract method. And remember, a functional interface can extend another interface only when it does not have any abstract method. And that's not possible with functional interfaces, right? So the answer for this question is clear no. Next up, we have what is the difference between map and FlatMap function. In Java, the stream interfaces has map and FlatMap methods and both have intermediate stream operations and return another stream as method output. Both of the functions map and FlatMap are used to transformation and mapping operations. Map function produces one output for one input value, whereas FlatMap function produces an arbitrary number of values as output for each input value. The syntax of the map is represented as R stream R map function super T extends R mapper, and the syntax for FlatMap is also given on your screen. Here you can see that R is the element type of the new stream. The stream is an interface and T is the type of stream element and mapper is a stateless function that is applied to each element and the function returns the new stream. Then we have map can be used where we have to map the elements of a particular collection to a certain function and then we need to return the stream which contains the updated results. Whereas FlatMap can be used where we have to flatten or transform out the string as we cannot flatten our string using map. That brings us to the next question on our list. As interfaces can also have concrete methods from Java 8, how do you solve diamond problem and provide the step-by-step approach for the same. Now, diamond approach is basically a conflict of classes inheriting multiple methods with the same signature. To solve this diamond problem, Java 8 proposes three rules. The first one is select classes over interfaces. If your class inherits multiple methods within the same signature, then a method from superclass is selected. Remember, a class can inherit only one class. Then there is another rule which says select more specific interfaces than general interfaces. If your class doesn't extend any class and inherit multiple methods with same signature from multiple interfaces which belong to same hierarchy, then a method from most specific interface is selected. And finally, the last rule we have is use interface name dot super method name. If your class doesn't extend any class and inherit multiple methods with the same signature from multiple interfaces which don't belong to same hierarchy, then override that method and from within body explicitly call the desired method as interface name dot super method name, and this will allow your program to work smoothly. Next question we have for you guys is what will happen if you put the return statement or system.exit block on the try or catch block? Will finally block execute in this case? Now this is a very popular tricky Java question, and it's tricky because many programmers think that no matter what the finally block will always execute. This question challenges that concept by putting a return statement in the try or catch block or calling system.exit from try or catch block itself. The answer to this tricky question is that the finally block won't run if you call system.exit from try or catch block. Now the 15th question on our list is explain differences between internal and external iterations. Internal iteration was advanced in the Java SE8 version of Java, whereas external iteration was used in the older version of Java. Now, the next difference between both iteration is that in internal iteration, the iteration is done internally on the different object, for example streams, whereas in external iteration, the iteration is done externally on the different objects. Next difference is internal iteration is passive in nature, whereas external iteration can be called as active in nature. The major difference between these iterations is that there are less chances of errors in internal iteration, whereas there are more chances of errors in external iteration. But external iteration requires less amount of coding and internal iteration always requires more amount of coding. Next question we have for you guys is write a Java program to convert the array into stream. We'll visit the code editor directly to build a solution to this question. Here I'll create the program file first and we'll name this as array to string dot java. Now there are few functionalities that we are going to require here. So we'll import them. Import java dot util dot arrays. Then we are going to need java.util.stream as well. Now moving inside the body of public class a2string, will create the main method, that is public static void main string arguments, and now we'll create the array first. Next thing we'll do is we'll convert this array object into the stream object, and to do that what we are going to do is we are gonna use the stream functionality first. Stream for string will hold this stream1 which will contain the whole array that we have written above, and we'll also print this stream. Now there is one more method to convert the array into string, and that is using the stream function. So for that we'll use stream string stream2 equals to stream of method that we have also utilized previously, and now we'll print this stream. And one more thing, you guys can also observe that we are not using any iterable method here, right? We are using the for each method because iterables will never work on streams. So just make the point of that as well. Now let's run this code. Okay, stream 1. Now it should be fine. So let's run this code. Yeah, here you can see that A to F has been printed twice for two different methodologies. So basically what we have done is we have two methods to convert array to the string. First one is using java.util.arrays library, and the second one is using java.util.streams.stream library. We have two different methods. The first one is definitely arrays.stream, and the second one is definitely stream.off. So you guys can use both of these methods. And now let's move to the second last question on our list. Explain the permgen and metaspace. So guys, permgen is known as the memory space which is used for collecting class data like bytecode, static variables and many more. The space allocated to permgen is by default 64 MB. The permgen can also be attuned with the help of XX max perm size. In Java SE8, the permgen process area was restored with metaspace. Java developers have transferred permgen to the unique consciousness in the original OS, which is now commonly known as metaspace. Metaspace can auto-enhance its capacity by default. In metaspace, the classes can store and discharge during the total life sentence of the Java virtual machine. The last question on our list is find the first non-repeated character in a given string input using Java 8 stream. So without any delay, let's visit the code editor and understand the solution. So guys, first of all, in this program we have imported few important libraries such as java.util library, then function library and collectors. So basically we are going to use collectors for collecting the values that we want, that is non-repeated character. So then we have class here that is named as first non-repeated character. Inside this class we have defined a main method, and inside main method we are taking the input from user using scanner class. And after that we are creating first non-repeated character, and we are actually processing the input with logic function. So first of all, let's look into this logic function. This logic function has been declared private because we don't want to disclose the details of this function to user. So that's why we have made it private. It's basically a character function. Inside this function, what we are doing is we are taking the new variable that is result, and we are storing the stream of characters in it. Then what we are doing is we are mapping that stream, and then we are converting it to the lowercase. After that, what we are doing is we are storing the elements of the stream in linked hash map so that we can map each character one by one. After that, we are taking the entry set stream and then we are filtering it. And finally, we are mapping that values into key pair format. We are printing that element. So let's run this code and check if it is working fine or not. So guys, it is asking us to enter the statement. So let's say we enter this statement. Yeah, and here you can see that the first non-repeated character is P, which is the exact output of this problem. I hope this problem statement and the solution is clear to all of you guys out there. That's all we have for this session. Thank you so much for being here till the end of this video. I wish you all the very best in acing those technical interviews. If you want to come across more such technical videos, make sure that you hit that subscribe button and stay tuned with Intellipaat YouTube channel.
Just a quick info, guys. Intellipaat provides Java certification online training, mentored by industry experts, the course link of which is given in the description below.